Hello everybody, my name is Imran and today I'm gonna show an overview of Ethereum Whitepaper. It's the next generation smart contract and decentralized application platform. I have some topics to cover today. First of all, I'll go through the main theme, then I will give some information about Bitcoin and existing concepts. Then I will try to give an overview of Ethereum and its applications. And lastly, some concerns about this technology. So, first of all, we need to talk about Bitcoin because this is the parent of every cryptocurrency. And Bitcoin was born at 2009, and that day can be think as a revolution because this was the first asset that had no backing, no centralized controller, and it was using blockchain. So blockchain technology has some unique features like colored coins, smart property, name coin, smart contracts, and centralized autonomous organizations. And Bitcoin is not using all of them, but here we have Ethereum, and Ethereum is a blockchain that is a Turing complete programming language, and that can able to use those features of a blockchain, and we can actually create our own applications that need not to be just on money but on anything, and we can create anything to be imagined. So Ethereum is actually a platform. Okay. So the next, some history of Bitcoin and other technologies. So decentralized digital currency is not a new idea. It was from 80s and 90s, and Bitcoin was created 2009, and before that there was some attempts to create some decentralized currency. For example, in 1998, B-money was proposed as a centralized consensus fashion of getting money by solving computational puzzles. But it failed because it wasn't detailed in how to implement decentralized consensus. Again, there is a piece of work called Reusable Proofs of Work in 2005. But it also failed because it was relying on trusted computing. And finally, in 2009, Bitcoin was created. And that was a combination of its preprocessors. So this proof of work is a very amazing feature because it's simple and effective consensus mechanism, because node can all agree on the state of Bitcoin ledger, and always it allows free entries to become miner. So it can also prevent different ear attacks like Sable attack. It also it does also through an economic barrier, okay, where you need computing power. So next, Bitcoin as a state transition system. So here you can see we have a state, and after a transaction it's becoming another state. So it's called state transition system, where you can have one state that is called a ledger of balances that can transition into a new state with an updated ledger of balances. Okay, and this state is just a collection of coins or UTXOs according to Bitcoin, okay? But there is no list of owners and balances, just UTXOs, and those UTXOs will stay who their owner is. And thus the owner is able to actually spend it. Okay, so that is about Bitcoin's transaction system. So after that, we can talk about mining. So we can just save the ledger on a server. That would be a centralized. So instead, what we need to do the whole thing as decentralized. So we gotta make sure a ton of new nodes agree on a common history, and this history is very important. So say these are some examples of blocks, and we can do this by making the nodes consistently trying to create new blocks to add to the longest chain. A new block is created in every 10 minutes. And in a block, we have 3 different information like timestamp, nonce, and reference to the previous block. Okay, so next slide, it's called Merkle trees, and these trees are very important, and because we don't want to store our transaction within the block, within the same block. Instead, we are using everything. We are storing everything inside the Merkle tree because we want to save space. And a Merkle tree is a binary tree where each node is just hash of its children. And these children have leaves, and those leaves are called transactions. The root node is called the final hash, is the only thing that's included in the blockchain. Okay, so we can also validate a transaction, okay, and we can just compute the hashes to see if the node matches your newly computed hash, and we can validate the transaction using this. So that's it. Next, scripting. So in Bitcoin, we can actually implement smart contracts. This means that in order for a transaction to pass, it must be verified by smart contract itself. We can do this using multisig, that is called multiple parties confirming for something to pass, or decentralized cross cryptocurrency exchanges. But there are limitations like lack of Turing completeness, namely missing loops, and inefficient space, and same problem is value blindness, again lack of state, and blockchain blindness. So lack of state means UTXOs are spent or not spent. It's hard to have states between. Blockchain blindness means UTXOs can't even see the blockchain data. Yeah. So all of these limitations mean we get around it in 3 ways. So we can create a new blockchain, or we can script on top of Bitcoin. Otherwise, we can build a meta coin on top of Bitcoin. But each of these 3 ways has drawbacks. So here comes the Ethereum, and Ethereum makes it easier for people to build applications on top of it, while it's tied with an economic environment and security of the blockchain. So Ethereum is all about providing a platform to build dApps. They're optimized for rapid development times security issues, and efficient interactions. And Ethereum is a Turing complete programming language. So it's value blockchain and statewide blockchain. So we can create whatever distributed application we want. So next, let's talk about Ethereum accounts. There can be two types of accounts. One is externally owned accounts, another one is contract accounts. Externally owned accounts are controlled by private keys or peoples, and they don't have code, but they can send messages, and those messages are called transactions. And we have contract accounts that are controlled by contract code, and when they get a message, first they activate and execute their code, and these are like little robots that execute their code but also have their own Ether balance. And every account has 4 fields like nonce, Ether, contract code, and storage. Okay. So next, message and transaction. Transaction in Ethereum means it was signed and sent by people. And a transaction contains several things like recipient of the message, signature of the sender, amount that is being transferred, optional data field, start gas, gas price. Okay. So that's it. And next is Ethereum state transaction function. So here there is an algorithm how we translate one state to another. So this is our algorithm. So first of all, it checks the transaction is filled out or not, and then it checks the signature validation. So the nonce should be as sender nonce. First step is done. Next step, calculate the transaction fee, and it's the multiplication of start gas and gas price. So what we are doing, we are finding the sender address and subtract the transaction fee from the balance and increase the nonce. Then we will initialize the gas. After that, we send money to the receiver. If the receiver does not exist, we create an account. Then if there is a failure, revert everything. But the gas we have already paid is gone because there are some miners involved in this process. They already computed various things. So that money will go to the miners. So else refund the remaining gas fee to the sender. So that's it. And let's talk about code execution. So all code in the Ethereum is written in low-level stack-based bytecode. And there are 3 types of place where we can actually store those data. First of all, we have stack, memory, and storage. Stack means last in, first out container. Memory means infinite expandable array. And storage can be considered as long-term storage or key value storage. And this kept on the blockchain. Okay. So blockchain and mining. So there is a block validation process. While mining, we need to validate something. So just a quick overview of the algorithm. Like first of all, you will check if the previous referenced block exists and it's valid or not. Then we have to check if the time span of the block is greater than the previous block and less than 15 minutes in the future. It's very important to check. After that, we have to check the contents of the block are valid. So by content, I mean block number, the difficulty, transaction route, uncle node, and gas limit. then we check the poll, then we execute all the individual transactions, update the state, pay the miner, and check if the Merkle tree root of this state is equal to the final state root of the block header. And after this, our our block validation is done. So storing everything in Merkle tree seems inefficient, but most of the tree isn't actually going to change for the most of the time. So we introduce a different tree, or we use a different tree that is called Patricia tree, and that tree actually can save 5 to 20 times saving in space. Okay, so let's talk about some applications of Ethereum. Basically, there are 3 types of applications: financial applications like subcurrencies or financial derivatives and so on, semi-financial applications, and non-financial applications, says DAOs on online voting, that kind of thing. So, and we have other applications like token system, financial derivatives and stable value currencies, identity and reputation system, decentralized file storage. It's the new thing, and it's becoming very popular nowadays. Decentralized autonomous organization, and we have decentralized data feed, cloud computing, on-chain decentralized marketplaces, and so on. So every day new applications are coming on, and we'll see what happens next. Then we have some concerns. Every technology has some drawbacks. Ethereum, Bitcoin also have some drawbacks. The first one is modified ghost implementation. So ghost means greedy, heaviest observed subtree. So there are 2 problems with blockchain. First is high stale rate, meaning you did all the work to get the right hash, but it's useless. How? Since it's first to find the block, the bottleneck is because of the propagation through the network. There's a lot of nodes end up wasting computation and not contributing to the security. So it's the problem actually. And there is also a centralization problem. The bigger your mining pool, the more efficient you are with your computation. So this gives an edge over those with less mining power. Thus, when you combine those problems together, fast confirmation times allow for mining pool to have a monopoly over the mining process. So Ethereum has implemented some strategies to solve these problems, and it's going on. Second problem is fees. So if you publish a transaction on blockchain, the whole network has to download and verify it. So because someone could do this to attack the network, thus we need to regulate it. And Bitcoin solved this by giving some fees to the miners. Okay, so this is actually a problem. The next problem is computation and Turing completeness. The Ethereum is Turing complete. So in order to do loops, they have some jump function, and sometimes we got infinite loops. So that could be a problem. And some problem with currency and insurance. because it's not about Ether though. It has sub units, and after that, mining centralization. This is a big problem regarding Bitcoin because most of the miners, they don't verify the blocks. They rely on mining pool. Okay, and there are 3 main mining pool, and more than 50% of processing power is using on those. So there could be an attempt of 51% attack. Okay, but Ethereum works a different way. So even if there are some trusted nodes, they cannot do this. And the last of all, scalability issue. Bitcoin is currently more than 15 GB and it's becoming large. So Ethereum is not only handling the currency problem, it also have other applications on top of it. So these scalability issues are need to be solved very soon. Other than that, Ethereum is going to shine. Next, conclusion. So Ethereum is the upgraded version of cryptocurrency that allows for the existence of smart contracts and dApps through a Turing-complete programming language. But the interesting thing is that Ethereum can actually do more than just money, more than this system. So we can actually play with decentralized file storage, computation, prediction markets, and so more. So it adds an economic layer between peer-to-peer protocols and help fields that do not relate to money. So there are many things to come in future. We are seeing NFT, multiverse, all of these things are rising, and Ethereum will play a great role in this era. So that's all for my presentation. Have a nice day. Goodbye.